Okay, so now we are on the last phase of our event today, and we have Sharzodbek Ibrahimo. Thank you so much for coming, Sharzad. Great to have you again on the other tug. We recently had him on the tug as well. So, okay, I'll just start with his introduction. You can follow him on Twitter at IB Sharzad. And about his journey, he's a senior data analyst at Park University. He began his journey with Tableau in July 2016 and has more than 10 years of experience in analytics across various industries. He initially joined the Tableau community to find answers to his questions on the forums, and also now he became an active participant in community challenges, participating in Mako Monday, P2P, Back to His Basics, and more. Like he has been a very active participant. And fun fact about him is he is a certified accountant, which is similar to USS CPA credential. That's a lot of studying. And he holds bachelor's and master's accountant degrees, but never ended up pursuing this path. And his presentation today is going to be understanding, identifying, and handling outliers in Tableau. So I won't take much time. I'll hand it over to Sarinzal.
All right. Thanks so much. Thanks for the introduction, Prasan, and thanks for having me here. I'm a little honored to be here. I'll just go ahead and jump to my presentation. I know we already spent more than like almost 2 hours, so I'll get to the main point, to the crazy stuff. All right. Just gonna make sure that you can see my screen.
So today I'll be talking about the outliers and how to identify them using Tableau's built-in feature, and also using the calculated fields. And also I will be talking about the ways to handle the outliers strategies. This is sort of information about me, and like person introduced me, I started my journey with Tableau in 2016. And since then, I've been involved in different community projects, and lately I've been involved with the community projects such as Makerman, the Back to Visual Basics, and other ones. And humbly, I was featured by Tableau in several times, and I also offer mentorships, visa review, and a top mate. If you want to check it out, it's free of charge. And you can always connect me or follow me on LinkedIn and the Tableau public. And this is some of the examples of the visualization I built for the last few months. In case you've seen it, that's me. All right, small disclaimer. This is not a comprehensive presentation, and there are more methods available, but I will be only cover some of them. And this is intended for general audience, so it's not specific for the data scientist, data analyst, or statistician, just for general purposes. And I'm always open for improvements and feedback. All right, today that's gonna be the very short. My agenda will be very short, so keep it short and sweet. All right, what will be definition of the outliers? It's an outlier, it's a data point, event, or item that is significantly different from other observation in the data sets. And examples will be here in the picture, you can see that every fish here, it's swimming to the left, but unfortunately, the red one is swimming to the right direction. So totally there's something going on here. Or say you planted the tulips, they're supposed to be the red and you end up getting one yellow one. Or say you are producing the balls, they're supposed to be blue and same size, but you end up getting one with a red and a bigger size. So these are the examples of the outliers, and the reason they could happen because either because of the variability in the data set, could be error, or it could be just a rare event, just one-off event. All right, what kind of role they play? The first, whenever there is an outlier, they can indicate there's errors in data. And they could be highlight the data variability in the distribution. It can also detect us the rare events. It can potentially influence our statistical analysis. And because of that, it can also tell us the ways to improve our predictive models. And of course, because of the outliers, it could also help us to uncover the important patterns and issues. All right, let's take a small study case so we can better understand it. Let's say we're in the business of selling main suites, and there was requested to find the average customer height, and we end up getting the result that on average, the main suites, the average size of the main customers were 218 centimeters, a little over 2 meters, or about 7 feet and 2 inches. Meanwhile, the average US men's average height was 175 centimeters, so about 5 feet and 9 inches. And here, we can ponder what's going on. It's a big difference. And to get into the cause of this, the big difference, we can look at the underlying data. And as we can see from a picture, that we are able, like there was one person which is way off from others. That's probably what is causing us the result average to be higher. And if we look at the centimeter, at the height in centimeters, we are getting something between 168 centimeters to 172 majority, but one person is 510, which probably doesn't exist, that person. It's just to get to the point to show the what could happen. And that's why we get in the, when we're averaging, we are getting 218 centimeters, which is totally off from the US average. And what we should be doing instead, we should be exclude something like that because it's a one-off. There's the rare event that we don't get this kind of the person. And we should be using the normal sizes, the heights. And the average will get about 169 centimeters, so about 5 feet and 7 inches, which is very close to the US average. All right, this is kind of comic. I was able to find how much the outliers can change the direction of the game. All right, so what could mean when we don't take care of the outliers? It can distort our mean, variances, and statistical measures, just like I mentioned. Because of the one person, our mean went off. And it could also bring to the it could bring to the misleading trends. It could also bring to the biased predictive models. It reduced the validity of the statistical tests and confidence intervals. And also it could influence misleading information, or like the distorted means could lead to the incorrect conclusions. Okay, there are mainly three types of the outliers. There's the first one is global. So the data point which lies abnormal distance from others values in data sets. And as you can see in the picture, all pink one, they are very close to each other and they kind of forming the one trend, upward trend. But there's a purple on the left top corner is a purple. It's way off from others, and that's why it could be the global outlier. All right, and there's something called a contextual outlier, which is observation that is significantly different from others. That is based on the specific context of the analysis. And I'll show the example here. So imagine in the y-axis, I'm gonna keep it empty for now, some kind of measure. And on the x-axis, we have and from January through the May, we have the numbers going up, and the June we're dropping, and again the July going up, and eventually is going down. So now I know there's something wrong here. It's in the June because it went down, and we know it's an outlier. But can you guys guess what could be the y-axis? Any guesses? Well, probably it's gonna best guess will be the temperature, because during the May, June, July, August, we see like the peak in the temperature, and unfortunately seeing this June temperature going down below the, being very low, it's abnormal. There's probably something happened, and this in the context of this, the temperature in the month, this can be outlier. And another one will be the last one, the collective one. It's very similar to the global one, but instead like a single one, it's going to be collection of values that are different from the entire data set. That might be not the best visualization, but just to get the point across. So we have the pinks spread out and the purple one kind of off from others. All right, there are several methods, but I will cover on a few of them. The one of the standard deviation. So eventually the standard deviation identifies the data points that are deviates significantly from the mean. And usually we use a specific number standard deviation from the mean. And the practice usually you use either 2 or 3 times of standard deviations, plus or minus. And a formula will be something like this. And this is the formula, it's sigma, it's for standard deviation, and that's how it's set up. And the good news, you don't have to do it manually. The Tableau has a built-in formulas for it. And this is how the visually looks like. So usually our data, anything within the three standard deviations, we have about 99.7% of the data. They are within the 3 data standard deviation. Anything above, just like a less than 1.1%. All right, and now I will be going into a more practical aspect, and I will be using Tableau that I built it. So the first, like I said, we can use the Tableau's built-in distribution band feature, and to get there, Tableau has an analytics pane, as you know. All you have to do, go to distribution band, drag and drop, go to the table. Now it'll give us option. Make sure you go to computation. Make sure you click on here, and we have several options. And the one we'll be using right now, it was standard deviations. And again, it defaults to -1 to -1 to 1, but we're gonna change to 2 for this example. And make sure you select the population. That's what we are using right now. All right, and just here for now. There we go. And we just built the Tableau's built-in standard deviation band, distribution band. So what's really happening? Anything this line above will be the outliers, and we can visually can see there's three the events or like a data points that are outliers because they are about 2 standard deviation from the mean. And at some time we can see here this number, it's 2 standard deviation below the mean. So those other will be the points that are outliers, and that's how we are visually can see it. But what if we want to use a calculation, we want to exclude them, right? For some reason. And unfortunately, you can do either manually or you can use the calculated fields, and we get there. And that's all we'll be using it. And right now for already built in. So again, we have to find out what will be the upper and what will be lower standard deviation. And anything above will be the outlier, anything below will be outlier of these lines. And for example, to get the upper, so the first one, if you remember, we have to find the average. The average will be here. And now we have to multiply by the 2 times of, and that's why I set up my multiplier. It's a 2 times of the standard deviation. But again, Tableau has a built-in standard deviation formula. So all you have to do is just bring the measure that we'll be using it. And for lower, it will be exactly the same, except it's going to be minus. So we are deducting the 2 times standard deviation from the average. So now, once we can bring this here to here, and it will use as a reference, and that's why you get those 2 lines here. And the last one will be we will use the outlier filter. They will use as a filter, or we use as the color. So what's really happening? We are saying anything about if the sum of profits are greater than the upper band, or if the sum of profits is lower than the lower band, it will be outliers. Anything between these two lines will be normal. And we're gonna color it. I'm using on the second one. And once we color, we get in this nice one. So we can visually see that anything about these lines are the red ones, which are outliers. And the one in the below is outlier. Anything within, there are normal ones. And now, like I said, we use it as a filter. Now, if for any reason we end up need to exclude them, we just click here, normal one. Now we have the values within they are excluded, the outliers excluded the normal values. All right, and this was the first standard deviation. We'll go back to the presentation. All right, so now there's another one method called interquartile range. It's something we probably have seen it. You heard about is a box plot, or box and a whisker plot, or IQR for short. So eventually, I will go over the definition very quickly, but as we get the examples, it's going to be much more clear. So now it is detects the outliers based on spread of middle 50% of data. There are outliers. So the outliers are considered when they are below the lower the fence, below the lower fence, or above the fence. And that's how the formula is. And to get the IQR, so this IQR, it's from quartile 3 and quartile 1, we have to remove them. And that's the way it looks like. So this is a quartile 1, this is a median, and this is a quartile 3. So anything between difference will be the interquartile range. So once we apply the lower or upper fence, the formula, anything below the range will be outliers. Anything above the upper fence will be outliers too. All right, and I'll get to the example. All right, and like I said, the first one we'll be using the Tableau's built-in box plot. And again, we go to the analytics pane. And right now this is gray out because we already use it. So all we have to do is just right click and remove for now. And now we have a box plot option available. So if it is just drag and drop, voila. And it already shows us the box plot, the option. And as we visually can see that this data point here, it's outlier. But here nothing looks like they're just on the line, so it's not the outlier. So physically we can visually can see this is just only outlier. And again, just since it's just 1 point, we can manually exclude them. But again, now we can also use the calculated way, and that's what I did. So now we're gonna use a little bit. A couple of there's kind of steps. The first we have to use the quartile 1, quartile 3. Then we're gonna get the upper fence and lower fence. The first we're gonna go the quartile 1, which will be using the Tableau has a built-in percentile formula. They gets the percentile of the first quartile. And all to do is just bring the sum of profits, and here the 25%. And quartile 3 will be 75%, or just you have to use a decimal. It's gonna be 75%, the same formula. Then we have to use the IQR, will be difference between a quartile 3 and 1. That's gonna be the difference. And then we have to get the lower and upper fence. If you remember the way it does, you are adding to this is the quartile 3, you add a 1x half of IQR. And to get the lower one, it's the same thing, except that you are using the quartile 1 here and minus 1/2 times of the IQR. And then to get the outliers, we are saying if the sum of profits are greater than the upper or the lower one will be the outlier. That's exactly what we're doing here. So we are saying that if the sum of profits is lower than the lower fence, or sum of profits are greater than the upper fence, they will be outliers. Anything else between, it will be normal. And when I bring them to to the color, and that's what we're getting. That's going to be outlier just because it's above the upper fence and there's nothing on the lower fence. And again, we can exclude them using the formula. All right. The next will be, I'll be talking a percentile. It's a very straightforward one. So pretty much what it does do, anything falls outside the specific percentile, outside the percentile, above or below, it will be the outliers. And for this one, usually there's a 5th or 95th percentile, first and 99 percentile, or say like a 90 to 10 to 90%. So end of the day, they should add up to 100. All right, and it's very straightforward. And now I will be using the Tableau again. So again, we can use the Tableau's built-in distribution band. So again, we go to the analytics pane, go to distribution band, and make sure a table, and we are using the sum of profits. Now we go to computation and make sure you click here and use the percentile option, and you get the one percentile, 95th percentile. But again, what the method I'll be using, we're using the upper and lower percentile. So all you have to do is just click the drop down menu, and you can click here, enter one or two values. But again, usually they can 99, 95, 90%, but again, this is more subjective one. But for this Excel, I'll be using 99. So all you have to do right now, I have option to enter 1 percentile and 99 percentile. And voila. So what's really happening? It's calculating percentile for the whole data set, and looks like between the 1 and 99 percentile, this whole data. Anything about 90 percentile, this that will be the outliers, and this one, the below the 1 percentile, will be the outliers too. But again, we can visually see and we can manually exclude them, but there is a way you can calculate this one, and we get there, and we can color them too. The first, again, Tableau has the built-in percentile formula available. So the one, if you remember that we did in the first and the prior one. So when this percentile, the sum of profits, and we're using the decimal. So 1% will be 0.01, and we will be calculating the 99 percentile. It will be 0.99, the same formula. When this percentile, and using sum of profits, and we're entering the decimal. And now the formula will be if the sum of profits are greater than the 99 percentile or below the 1 percentile will be outliers. Anything in between will be normal. And that will be the formula for it. So we're saying if it's sum of profit less than 1 percentile or sum of profits greater than 99 percentile will outliers. Anything in between will be normal. And we bring into the color, and that's all we get in this option. Again, we can exclude them quickly, and now this data shows only the normal, excluding the outliers. All right, and there's going to be something called z-score. It's very similar to the standard deviation. It just it calculated a bit differently. Just like you have to above the certain threshold. Usually they use 3 z-scores, and that's what the formula. I'm not getting, for sake of the timing, I'm not getting very deep into, but my worksheet has this the calculations available, and that's how the distribution will look like. So the anything about the 3 z-score, anything below the 3 plus or minus, above the 3 or below the 3, there will be outliers. All right, and how we will be handled in the outliers. The several ways we can do it. The first one, the obvious one, is to remove them. And this one, by removing the outliers, we simplifying the data set, excluding the extreme or rare and the rare values. This we did with the small case that we did together. And you can transform the outliers. They usually can be done by using mathematical transformation. It's by converting the logarithmic, or you can square root, and that's going to help you to transform outliers. So you are less sensitive to your data set will be less sensitive to the outlier. The input outliers, eventually you are replacing the outliers with some of the values. They can be a mean, median, stuff like this. And the fourth one is a more of statistical method. I'm not getting into it. Eventually, you are using statistical, which are less sensitive to outliers. All right, that's all my presentation for today, and I hope you find it very helpful. Again, this was just a short introduction to outliers, and I will be publishing my workbook on Tableau Public. You can go ahead and download it, and you can reverse engineer and see how I did it. You can follow me in the Tableau Public. You can follow me on the LinkedIn. I'm here, and if you don't have any question, that's all for today. Thanks so much. It was my pleasure to present today. Thank you.